Good morning. In the last lecture, we started with logic. Initially, I explained the concept of logic by defining statement. Then we discussed logical connectives with their truth tables. Now, exercise 1.1, fourth one. If the statements P and Q are true statements and R and S are false statements, then determine the truth values of the following. Now, this type is important from both exams, for board exam and for CET exam also. The first one, what are the truth values of P and Q? T. Truth values of R and S? F. Now, the first part, P or Q and R. See, this is not difficult. Now, this is true or in bracket true and false. In CET, we will not even check this because in disjunction, if one is true, answer is true only. Actually, this is false, but true or false is nothing but true. So, what is the truth value? It is T. This is how you have to solve this. Write down. Second, P implies Q or R implies S. Now, true implying true is true or false implying false is also true. So, true or true, which is nothing but true. Third one, Q and R or not P and S. True and false is false. Not true is false. And what is false and false? False. So false or false is nothing but false. Fourth one, P implies Q and not R. So true implying true, that is true. Not false is true. So true and true, that is true. Sum number 5, not R biconditional P implies not Q. Now not R means not false, which is true. True biconditional true is true. Not true is false. True implying false is false. Now next one. You have to write this. I'll give you time for that. Actually, first you should try. This is the solution for sum number 6. Write down. Finally, you have to say truth value of the given statement is false. See, not P and not Q and R. So not true and false. Let us consider this bracket first. Not true is false. What is false and false? False. So effectively, false and false is false. Second bracket, true and false is false. Here also false. What is false or false? False only. So disjunction of false and false is again false. Write down. So this is 7th and this is 8th. Okay. Now the next question, 5th one, write the negations of the following. See, you have to use the word or at a proper place. That's it, because all these are simple statements. Now I'll just dictate that. First one, Tirupati is in Andhra Pradesh. I'm talking about sum number 5. Tirupati is in Andhra Pradesh. So what is the negation? Tirupati is not in Andhra Pradesh. So you have to use the word not at proper place. I hope you won't say not Tirupati is in Andhra Pradesh. No, Tirupati is not in Andhra Pradesh. First one. Second, what is that statement? 3 is not a root of the equation x square plus 3x minus 18 equal to 0. So can you tell me the answer? Write down. 3 is the root of equation. Simple. 3 is a root of the equation x square plus 3x minus 18 equal to 0. Write down. Number 3. What is the given statement? Root 2 is a rational number. So what is negation? Root 2 is not a rational number. Root 2 is not a rational number. Now you may say, sir, can we say that it is not true that or it is false that? Yes, you can. But why? Why not to use the word not at proper place? Fourth, what is the statement? Polygon ABCDE is a pentagon. So what will be the negation? Polygon ABCDE is not a pentagon. Is not a pentagon. Now tell me what about fifth? Negation of 7 plus 3 greater than 5 is 7 plus 3. Don't say less than or something. Say not greater than 5. That's it. You may say, can we say 7 plus 3 less than or equal to 5? That is also correct. But why to say that? 7 plus 3 greater than 5? Negation is not greater than 5. Now we discuss the concept of statement pattern and logical equivalence. After that, we will discuss the concept of tautology, contradiction, and contingency. Now, what is statement pattern? The expression constructed from logical statements PQR, which take on the truth value either T or false, along with logical connectives. Which are the logical connectives? This is and, then or, then not, implies, biconditional, is called a statement pattern, which is generally written as statement pattern consisting of these statements. Okay. For example, P implies Q or R. Okay, this is nothing but a statement pattern. Now, to find the truth values of the statement patterns, we must know the concept of that truth table. That is, we should know how to prepare the truth table. Okay, so this is nothing but a statement pattern. What is logical equivalence? Two statement patterns, S1 and S2, are said to be logically equivalent. Two statement patterns, S1 and S2, are said to be logically equivalent, or we can just say equivalent or equal, if they have identical truth values in their truth tables for each combination of the truth values of their components. I repeat this. Two statement patterns, S1 and S2, are said to be logically equivalent or equal if they have identical truth values in their truth tables for each combination of the truth values of their components. So in this case, we write this as S1 equivalent similar to S2, or just S1 equal to S2. Is that clear? Now, two statement patterns, S1 and S2, are logically equivalent if their biconditional is always true. right? So the truth value of S1 biconditional S2 is always true. I hope this is clear to you. Now we will start solving some from exercise 1.2. Okay. Let me read the sum. I think it is on page 13. Construct the truth table for each of the following statement patterns. The first one is, you have to be very careful regarding the bracket. It is what? P implies Q and Q implies P. Do not open the bracket as per your convenience. See, there are how many? Let me explain first. There are how many? 2 statements. And how many connectives? 3 connectives. So there are obviously how many rows? 4 rows, because for P and Q, 4 combinations are possible. And how many different columns will be there? Are we supposed to find not P, not Q? No. So 2 plus 3, that is in all 5 columns. So let me explain first. First is P, second is Q, right? Third is P implies Q, then P implies Q and R. Okay, and finally put this in bracket. P implies Q, here also you should use bracket. P implies Q and R, bracket complete, implies P. Now some students say this is column number 4. So 4 implies P, right? Because I don't think if number of columns increases by say 2 or 3, you won't be able to write this. So choice is yours. Now, true, true, false, false. I repeat that ideally order is immaterial, but in exam, you are supposed to write these truth values in this order only. Here, true, false, true, false. Let me explain. P implies Q. True, false, true, false. You should not waste time in remembering what will be the entries in the column. You have at the most 5 to 6 seconds to write these. Now, P implies Q and R. And R, what is that? Not R, I'm sorry. The first one is P implies Q and Q. I'm sorry. This is not R, this is Q. R मैंने Q लिखा. Okay, I'm sorry. Now this is correct. P implies Q and Q. Now you should remember the table for and. This is conjunction. It is true when both are true. So can you tell me the entries? Entries will be, just check this, true, false, true, false. Yes. Okay. And finally, implies P. Now, true implying true. See the cursor. True implying true. Yes, true. Now, do not waste time because false. This is false. False can imply anything. So, directly write true. Now, you have to be careful because here it is true and truth is implying false. This is not done. So, F. But false can imply anything. Do not waste time in verifying false is implying. False can imply anything. So, it has to be true. I hope this is clear to you. So, what are the entries in the last column? T, T, F, T. In CET, you may be asked the entries in the last column of the truth table for this statement pattern. If you ask me, I think this question is not correct in the sense because the order in which these can be taken is immaterial. But if asked in this fashion, you have to consider order as TTFF, TFTF only. Okay, so this is for the first. Now you will try for second. Now third statement pattern, P and Q biconditional Q or R. Now here you will notice that there are how many? 3 simple statements. So how many combinations? 2 into 2 into 2, that is 8 combinations. So the first column headed by P, let me explain. 4 times T, 4 times F. Second column headed by Q, 2T, 2F, 2T, 2F. Third column headed by R, TF, 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 TF. I hope this is clear to you. Now P and Q as usual, true and true is true, then true and false. Rather this is P and Q, okay? So true and true is true, true and true is true, true and false is false. So in this manner, all 8 truth values are written. Q or R, true. Now when you see first as true, you need not even see the second because this is disjunction. If one of them is true, then also it is true. If both are, sone pe. So false or true, true. So all these 8 truth values are written. And finally, biconditional of these two. Now biconditional is true when both truth values are the same. True, true, true. True, true, true. False, true, false, and so on. So these are the entries in the last column. In fourth sum also there are 3 simple statements. So there will be how many? There will be 8 combinations in all. So first column P, second Q, third R, then we need Q and R, then its negation, and finally this implication. Q and R, true and true, true, true and false, false. When you see first as false in conjunction, you need not see the second, directly write false, false, true and true, true, and so on. Then negation of this. So true changes to false, false changes to true, and so on. And finally, P implies. See, let me explain. False can imply anything. So for the last 4 entries, here it is going to be true only. Now, question is for the first 4. So true implying false, not done, false. True implying true, yes. True implying true, yes means true. And true implying true, true. So all the entries except the first are true. Now in fifth sum, first column will be P, second will be Q, but note that we need not P, not Q also. Okay. So first 4 columns P, Q, not P, not Q, then P or not Q, then P or not Q and Q, and finally this. Now you may say, you may give numbers 1, 2, 3, 4, 5, and then you may say 4 and Q. Okay, and so on. So that can also be done. See, all the entries in the last column are F. Afterwards, we are going to call this as contradiction or fallacy. This is for sum number 5. Take your own time. And in the next one, truth table is the same as that of what? Biconditional. Actually, sum number 7, 8, and 9 for homework. This is 10th one. P or not Q implies R and P. So first column P, second Q, third R. Note that we need not Q also. So that will be the 4th column, and so on. You have to be very careful. So for PQR, 8 combinations. Please consider these combinations in this order only. That is in the column P, first 4 entries true, then 4 entries F. Here 2T, 2Fs, 2Ts, 2Fs. Here TF, 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 TF alternately, and so on. So these are the entries. Just a minute. I'll show you this once again. This is solution for sum number 8, and this is solution for sum number 7. Okay. Now, second question, using truth tables, prove the following logical equivalences. So there are 10 in all. We'll solve at least 5. The first one, not P and Q, we have to prove that it is equivalent to P or Q and not P. See the first column, you have to give numbers. First column P, second Q, we need not P. Now many students make one more column not Q. We need not Q, we don't. So why to make that? Fourth column, not P and Q. Fifth one, P or Q, and this is the sixth one. So what is not P and Q? False. See, when you see false in conjunction, directly you have to write F. Okay. Similarly, second F, true and true, true. And last one is false. P or Q, true, 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 F. And finally, this is conjunction. So F, F, T, F. Now after this, we have to say entries in the columns 4 and 6 are identical. Therefore, ideally you should say, therefore, statement patterns, this one and this one are logically equivalent. Or just say, therefore, not P and Q logically equivalent to P or Q and not P. Right up. Second, not P or Q or not P and Q equivalent to not P. First column P, second Q, third not P. We don't require not Q, so you need not make that column. Fourth, P or Q. Fifth, not P or Q. Sixth, not P and Q. And finally, disjunction of 5 and 6. So, first two columns, you're not supposed to change the order. TTFF, TFTF. What will be not P? False, false, true, true. P or Q. See, you should be able to write triple TF directly. Then it's negation. So triple FT. This is not at all difficult. Not P and Q. Okay. So when you see F, you need not see the second. Directly write F. F, F. True and true is true. True and false is false. And then their disjunction. False, false, false. False or false, false. False or true, true. True or false, true. Now you will notice that entries in columns 3 and 7 are identical. So these are logically equivalent. Now this is the third one. P biconditional Q equivalent to negation of what? P or Q and not P and Q. Okay, so these sums are for homework. Sum number 4, sum number 5, then sum number 6, sum number 7. See, sum number 7 should be, please check this, it should be P implies Q and R equivalent to not P and not Q and P implies R. Okay, this is sum number 7. So this is sum number 8. Now we'll be solving sum number 9. Now there are three simple statements. So PQR, 8 combinations for them. Fourth column, P or Q. Fifth, its negation. Sixth one, not P or Q or in bracket P or Q. And seventh one is conjunction of this with R. You have to be very careful. So here you will notice that entries in columns 3 and 7 are identical. So these are logically equivalent statements. See, it is obvious that this part is nothing but R. Why? See this P or Q, its disjunction with its negation, it is going to be true only. Why? Because if this is true, yes, true or is true. If P or Q is false, its negation is true. So in any case, this part is going to be true. True and R is R. Because if R is true, conjunction is true. If R is false, conjunction is false. As simple as that. So it has to be R. Now this is for sum number 10. Fortunately, only 2 simple statements. So only 4 combinations. Right. Now this is an important part. Tautology, contradiction and contingency. Tautology. A statement pattern which has all the entries in the last column of its truth table as T is called a tautology. Simple example, P or not P. It is going to be true only. So in the above truth table for the statement P or not P, we observe that all entries in the last column are T. Hence the statement P or not P is a tautology. What is contradiction? It is also called as fallacy. A statement pattern which has all entries in the last column of its truth table as F is called a contradiction or fallacy. P and not P. Yes, all entries are F, so this is a contradiction. A statement pattern which is a tautology is true irrespective of the truth values of its components. Similarly, a statement pattern which is a fallacy or contradiction is false irrespective of the truth values of its components. What is contingency? A statement pattern which is neither always true nor always false is called contingency. Right? What is the example of that contingency? N number of examples can be given. Let me. Okay, this is C. TTFF. So this is an example of contingency. Is that clear? Now the last part is the tautology is usually represented by capital T and contradiction, that is fallacy, is represented by F. So that's it for today.